Okay, so in the previous lecture, we covered polymorphism. Now, one final issue to be discussed with respect to object-oriented programming is containment, also known as aggregation. Now, in simple terms, containment or aggregation is basically that in a class definition, say, for example, I created a class definition here by the name of course. As you can see here, there is multiple attributes of this course class definition. So I've got course title of type string, max number of students of type integer, number of lessons of type integer. Course lessons is an array of size 50 of type lesson, okay? And course assessment is another attribute of my course class of type assessment. Now, as you can see here, course title, max students, number of lessons, they were all built-in data types, string, integers, so on and so forth. But course lesson is an array of a type lesson, and course assessment is a separate attribute of type assessment. Now, what that says is that lesson and assessment, that means they are separate user-defined types. Now, if we studied very early on, the object-oriented programming is also a type of user-defined data type. So basically what I'm doing here is that in my course definition, I'm actually creating reference to another object. In fact, two objects, lesson, two types of different objects, lesson and assessment. Now, this is non-inheritance. This lesson and assessment are totally separate classes. They're not linked in any way with course. No attributes are shared. No subroutines are shared. None of that. But I am using these objects here as a type, data type in this class definition. And that is basically your aggregation. So you can basically refer multiple objects in this class definition. So for example, in my course, one course can have up to 50 lessons, and lesson is a separate class on its own. One course can have, in this example, I only have one assessment, but I can may possibly add an array to add more assessments, so on and so forth. So basically you can say that if say I were using the car and wheel analogy, a car is a separate object. It has its own properties. It has its own methods. There is no attribute sharing with wheel and car. There is nothing in common. It's a completely separate object on its own. But a car does have many wheels. Yes. And this is the essence of aggregation, that I am basically using an object as a data type in my other object. And we can do that, right? So as you can see here, in this definition, let's look at the Python example for this particular example quoted here. I am defining my course class. This is my course constructor. These are the constructor's parameters. This will obviously refer to the course title. This refers to the max number of students. Number of lessons is type integer. I have assigned it 0. Course lessons in array, since Python doesn't support defining arrays right away unless you give it an object. So right now I'm just calling it an array. The type will be defined later. So this is an array. And course assessment is a type of assessment, right? Now, obviously, before this course class definition, I must have defined the assessment class, because if I'm using this here, Python will assume that this is something of this name. There's a reference of this variable or this word created before. So before I can use assessment here in this definition, I have to first define what assessment is. So the assessment, if it is a class, which it is, I have to define the assessment class before. It's not shown here, but if when you're doing this, you'll have to apply this definition beforehand. Okay. Now these are the methods for my course class. So there's a method known as add lesson. In add lesson, what I'm doing is I'm incrementing a variable number of lessons by 1, because now there's one more lesson. So basically I'm simply incrementing. So you can see here, self double underscore number of lessons is equal to self double underscore number of lessons plus one. So now since a lesson has been added, I increment it by one. And since course lesson is an array, now pay close attention to what's happening here. My course lesson array is being added, is being appended with an object of lesson class. As mentioned here, course lesson is of type lesson. So my course lesson array is being appended with an object of lesson class. And obviously, lesson will always also have been defined before this course, before I can use it here. So both assessment as well as lesson classes have to be defined before the course class definition. Okay, and of course that's not shown here, but obviously this this is the lesson constructor being called, and the constructor will require three parameters, C, D, and R. Obviously the lesson parameters will be linking to the title, duration, and requires lab, so on and so forth, right? But what that happens here, that the first time for one particular course object, when an add lesson subroutine for a course object is called, it means that from now on, the course lesson arrays type has been defined as lesson, because Python, this is the way Python works. Unless you give it some value, the type of the array is not defined yet. So it's just an array. There's no type of array yet. It's not a string. It's not an integer because I haven't given any value yet. It's just a simple array. But when I call the add lesson method for a particular course object, and I pass it first, its first lesson, only then its type will become lesson from there onwards, right? Okay. Afterwards, you can see here I'm adding an assessment here. And assessment, the add assessment is sort of a setter method for my assessments, and assessment will be of type assessment. My course assessments of type assessment. So as you can see here, I'm accessing the course assessment attribute here, and I'm giving it an assessment right here. Now this is an assessment object. Of course, this has been defined before, and the assessment constructor will require two parameters here. So basically I'm assigning an assessment object to adding a course assessment as defined by the class definition. And output course details simply does what? Prints course title, whatever the object course is and the title is, with this string followed by the max number of students for that particular course. And I have a loop for all number of lessons, however lessons I have. So that basically had been updated every time I added a lesson to this. So the number of lessons that I have here, this loop will run for the number of lessons. And in every lesson, I'm simply, now, as you can see here, I'm accessing the lesson details. Now, lesson details is an attribute. Sorry, it's a method that is limited only to the lessons class. So I'm accessing the lesson attribute, lesson method to a lesson class object. And as you remember here, when I was adding course lessons, I was only adding lesson objects. So at each time, since it's an array, I'm accessing each lesson in my array, and I'm accessing the output lesson method for each lesson right here. So as you can see here, I'm accessing objects within objects. And this is the whole concept of aggregation. Now, let's work out an example of our own that applies aggregation. Okay, so the tire and car and tire analogy that we just discussed in the course would basically be used over here. So what we have here is that we got this class by the name of tire. This is the constructor, and it requires two parameters. Now, the first parameter is linked to the tire name. So by tire name, I mean brand. And the second parameter will be referred to the type. So that would be off-roading, all weather, and stuff like that. So type of tire, these two values, only these two, attributes for a tire class. And then I've got just one, I will keep this example short. So I'm just have one because I don't need any, setter functions because both attributes are being passed with constructor. And essentially I'm just printing the details here. So not adding getters here, but just printing details. So I've got just one method in my tire class, and that is t underscore details, and in which I'm just printing the details that I have. I can say get details and I can return them, but makes no difference. So in this particular application, printing is enough. So I'm just simply printing the name of that tire and the type of that tire. So this is my small definition of a tire class. Now, from this line onwards begins the class definition of vehicle. So if I have a vehicle, this is my constructor. It requires two parameters. I have the vehicle ID as well as the name of the vehicle, right? And afterwards, I've got a third attribute, which is tires is an array. Now, obviously, this array is meant to hold objects of type tire. So right now it's just an array, but when I use this code, it will be assigned with only tires. So at that time, the type of the array's type will be as tires, type tire. Now I've got a subroutine in my vehicle class that allows you to choose the tires and the number of tires you want for your car. And I called it set tires. So I take just one parameter here, and that will be the number of tires that your vehicle is supposed to have. That will be passed here. And in this subroutine, I also take input from the user that what brand they want and what type of tires they want. And I simply add this many tires to the car. Now, I need two local variables, name and type of type string. I take input from user, and I need a loop that runs with this length. And in each iteration, what I'm doing is that I'm adding to my tires array, tires.append, a tire object. And as you remember, the tire class requires two parameters, name and type. The values that I've just input here are sent as parameters to my tire constructor, like so. So this is sort of how aggregation is being implemented here. So you can say, this is my aggregation implementation right here. So you can say this is containment. Okay, so now what's happening in my main program is that, oh yes, one more thing. I am printing I have another method in my vehicle class, which is known as print details. And for which I print my vehicle's ID. I'm simply printing, I'm not returning, I'm simply printing them. You can add return if you want to use the values later on, print them in your main program. That's up to you. But this, for example, I'm just printing them. So what's important is aggregation, avoid doing that just fine. Okay, anyway, so I'm printing the vehicle ID, I'm printing the name, and another thing I'm doing with this v details method is that I am running this air loop for the length of how many tires I have, or the length of my array. So if I've got my car's got 4 tires, this loop will run 4 times. If my vehicle has, say, 6 tires, it will run 6 times, so on and so forth. So I am running this loop for the duration of the number of tires I have, and that's for the object underscore tires. And for each iteration, I'm simply doing what? I'm accessing the tires array, in which, if you remember, that I just mentioned that each index position contains a tire object. So tires array, I'm accessing each index position which has a tire object. And for that tire object, I'm accessing the method that is limited only to tire object, which is t details. So I'm basically calling the subroutine, the method t details for each and every tire object located in the tires array, which is part of my vehicle class. So there is no common attribute in either tire class or vehicle. There's no common attribute. I'm simply using a tire type of data in my vehicle class, and that's what aggregation is. Now in my main program, I'm asking for vehicle IDs as input, name as input. I'm creating a object by the name of my truck for some reason, and I'm calling a vehicle. I'm creating my truck is an object of type vehicle, and I pass these two attributes as required by the constructor for the vehicle class. And then I ask the user how many number of tires you want, take that as input. And then for that object, I'm calling my set tire method, and I'm passing the number of tires as a parameter. And then when that happens, control is shifted to my set tire subroutine, where I'm prompted for the name and type of tires I want, and I multiply that by the number of tires I've input, and I add those to my tire subclass. And after that, I'm simply printing the details of my truck, in which case the whole information, vehicle ID, name, and all the tires individually will be printed here. So let's run this code and see if it's working fine. Yes. Okay, so it starts off right here and it's asking me vehicle ID. So I'm going to give it 001, vehicle name, that is my truck. That's my vehicle's name. Number of tires, my truck has 6 tires. Tire brand. So now tire brand is now control, as you can see here, after taking in number of tires, I passed this 6 to set tires subroutine, and now current control is shifted to set tires, and this is the line that I'm currently at right now. The vehicle class is set tires method is being run, and which vehicle? My truck. So I'm at this point right now. So I asked the tire brand, I said Dunlop, and tire type, all terrain, call that, for example, all terrain. Now, as you can see here, when I print my details, since I had 6 tires, print details subroutine simply basically does that. I print the vehicle ID, that's 001. I printed the object's name, that is my truck. And then I ran a loop for the duration of my number of tires, which is 6. And in each iteration, I'm accessing the tire object, and I'm calling the T details subroutine method of that tire object only. So that means calling T details means I'm printing the tire's name, type, name, type, name, type, name, type, name, type 6 times. So that's it. That's how aggregation is used.